not. So an empty parrot cage is polygon. Anyways, polygon's a closed shape with the same number of sides and angles. Grab a highlighter, okay? It's good. A lot of these definitions are going to come back. Okay? Same number of sides and angles. The first difference is convex versus concave. And just think it's caving in. I'm telling you already though that 99.9, if not 100% of our polygons are going to be convex. Okay, this is what we're going to be dealing with primarily. So, but concave just means there's going to be a part that caves into the shape, so that way you have the definition. And then we have something very important. You have to know the difference between regular polygon and irregular polygon. And I focus on how to know whether or not something is regular. You need to meet two criteria to be regular. You have to have all sides measure the same. Okay, so we would say all sides are congruent. Make sure you write that down. And the second criteria you must meet is all interior angles are congruent. All interior angles are congruent. I would have this on my study sheet by the end of today, right? Just have a little entry under polygons. We're in chapter 2, right? Regular polygon, all sides measure the same. All interior angles are congruent. So same. All sides measure the same, all interior measure the same. So if you're not meeting both of these, you're going to be in the irregular polygon category. So this would be equilateral triangle. Would be considered a regular polygon, because we know that every single angle, the groups that we're doing that question 7 there, you know all about this. We have 180 degrees divided evenly amongst the 3 angles. So this would be 60, 60, 60. Okay? All sides are congruent. All angles are congruent. Therefore, regular. So an equilateral triangle is a regular polygon. But isn't it a triangle? Yeah, polygon is the category that encompasses all shapes that we're studying. Okay, it's kind of like the big umbrella. And then you have your square. You think a square would qualify? All 4 sides the same? It's got 90s in every corner. Okay. All angles are congruent. All sides are congruent. Therefore, regular. So we're going to draw more on the definition. Like when I say regular, you right away know, oh, it just means that all interior angles are the same and all sides measure the same. That's what we're going to focus on the most. Okay? Would isosceles, sorry, I'm going to break this down here. Would an isosceles triangle be regular? No. Because you've got 2 angles that are the same. But this one is not. This one is different. So this would be irregular. But then you have the rectangle. Rectangle is kind of like playing in between the lines here. What do we know about all angles in a rectangle? Right? All angles are congruent, but all sides are not congruent, correct? It's got 2 pairs that are congruent, not all 4 being the same. So it's irregular. So I hope that makes sense. Now it's just going to pop up from time to time. Again, I will do this one more time because every time I do one of these, if I emphasize it like 3 times and then highlight it, then you know it's probably important. Know how to identify a regular polygon. It's fairly easy if you just know what it's asking for. Okay. Next. I hope you're okay here copying. It's just highlighting right at that point. All polygons have interior and exterior angles. And this is huge. Interior and exterior angles are supplementary. They add up to 180. Okay. So in this particular polygon, does this look like a regular polygon to you just by observation? Definitely doesn't, right? So just keep that in mind. Sometimes it's very obvious. But how many sides does this have? N is equal to the number of sides in this unit. Every time you see N, it's number of sides. And this is how I want you to count, because it's going to vary. You're going to have 11, 12, 13, 15, 17. I want you to put a check mark on the side you start counting on. Right, so count that as 1, and then you go 2, 3, 4, 5. Can't tell you how many students miscount, and then everything else is affected. 5 sides. N is 5 means 5 sides. How many interior angles do you think this will have? Let's count. This is one interior angle. This is also, I'm putting an I every time there's an interior angle. How many eyes are there? 5, right? 1, 2, 3, 4, 5. So 5 interior. And here's where this is maybe new to you. Exterior angle. Every interior angle has an exterior angle that goes with it. So watch. You pick, I'm going to travel along this side, and when I get to the corner, I'm going to extend that and pretend like I'm not turning. And that angle that is outside here is an exterior angle. Okay? Keep traveling along it this way. And instead of turning, you just keep going. That's your other exterior angle. So you can tell, if you go around this shape, you're going to have 5 exterior angles as well. Five exterior angles. Can you tell that I and E are always going to add up to 180? I hope you see that. There's a straight, yeah, so, and I plus E is always going to be equal to 180. And this is where I derive 2 properties from. I can use this fact to say, hey, the exterior angle is going to be what? 180 minus I. So if I want to know the exterior angle and I do know the interior, I'm just going to subtract it. I can also derive from that in order to find the interior angle, I'm going to go 180 minus E. So from this fact here, I just rewrite it to give me these 2 options here. Okay. All right. Another fun fact here. Sum of exterior angles is always going to be 360. Regardless if irregular or regular, regardless of the number of sides. So, example, a 17-sided polygon will have 17 exterior angles. They all add up to 360. Okay, that's a cool property that if you were to find every single exterior angle in any polygon, it can have 100 sides, it can have 200 sides, it doesn't matter. If you were to add them all up, you always get 360. That's also a very important fact. I would just, all these things that are boxed in and that I'm mentioning, I would just have that on my study sheet if I were you, unless you're really good at remembering things. All right, next page. Here's where you're going to get a bunch of formulas. And these formulas need to be on your study sheet as well. Okay. So I think your homework, all it's going to be is fill up your study sheet. Okay. Next page. 33. Okay, so listen carefully. These are 5 formulas. And every time I talk about them, I want you to think for now of just one polygon right here. How many sides does this one have? 1, 5. Did you count already? Yes. N is equal to 5. 5 sides. That's where you start. One of the cool things about polygons is there is not a single number on here, but you can figure out angles just like that without any numbers given to you. And you'll be using these formulas to do so. Okay? How many interior angles does this thing have? 5. Yeah. Just put a bunch of eyes there. Yeah. Okay. So polygons are pretty cool when you start thinking about them. Formula, so n is number of sides. S of n, so don't let this throw you off too much. I will usually just go S, okay? But this is kind of like a function. So S, when you put in the number of sides, if you were to go number of sides minus 2 times 180 degrees, it calculates the sum of interior angles. So whenever you have your formula, also tell yourself, what does it do? Okay? I is n minus 2 times 180. Look at, is it copy paste, right? But in this case, you divide by n, number of sides. It calculates the measure of each interior angle. It only works with a regular polygon. Only works with a regular polygon. And here's where students sometimes mix it up, okay? There's this formula, but I just gave you another one. I don't know if you remember on the previous page. How else can you find the interior angle? You can use this one, right? So yes, that is still going to be the case. That doesn't change. So let's write those down. I will do that right underneath I here. Or I is equal to 180 degrees minus E. You can have that still going on no matter what. What do you need to know though for this one to work? You need to know this one right here. You need to know your exterior angle. If you don't know the exterior angle, don't use this one. You focus on, what is n again? Number of sides. Yeah, focus on that. If you don't know the number of sides, you can find it just like that. Central angle, it's 360 divided by n. Calculates the measure of each central angle. And again, this one only works if your polygon is regular. Exterior angle is 360 divided by n. Is there a typo, Mr. Dirksen? Because they're the same. No, there's no typo. It's supposed to be like that. Calculates the measure of each exterior angle and also only works with a regular polygon. And let's add the or. Or, how else can you find your exterior angle? 180 minus I, right? There you go. So this one is still applicable, but you need to know your interior angle if you want to use this formula. But I would definitely have the or here, that you can use it if you need to. D calculates the number of diagonals that can be drawn. More on this a little later as we're doing this right now. So let's do some calculation here. It says label ice, then calculate all of these things that we just talked about. SICED. you're psyched about polygons. I tried something, it didn't work. Is that still a thing? You still use that? You're going to be psyched about polygons. Anyways, it's not spelled like that, I know. So let's find ice. We've already done that. There's 5 of them, we've identified that. Okay, central angle, C. Think of center. Put a dot right at the center of this thing, and then you're going to make a pizza slice. I hope that one makes sense. So how do you make a pizza slice? You would go to this corner, and you would go from the center to the other corner right here. This is, that angle that results there is what we call a central angle right there. Exterior angle, I think you know that one already, E. I just need you to identify one. So go to the bottom, let's say, and then just keep going here. That is E, right there. So you've identified actually all 5 interior, didn't need to do that. But we went I, C, E. So I need you to know where they are. How many central angles are there though? 5, right? You could make 5 slices. So that'd be 5, right? Wouldn't it make sense that it's 360 divided by the number of sides to find your central angle? Because it's a full circle in here, right? So if you just want this one central angle, you take 360 degrees divided by just one angle, which is, right, divided by 5, you get the central. All right, so let's do some math here. So if I asked you to figure out the sum of angles, sum of interior angles would be 5 minus 2 times 180 degrees. That'd be 3 times 180 degrees. That's 540 degrees. So what is this saying? That if you were to go I, right, like 5 I's, you add all those up, you get 540 degrees. Okay. Next, what about the measure of just one interior angle, one of these I's? You would go 5 minus 2 times 180, just like before, divided by 5, not by 3. Some students divide this by 3 because they see that 3 there. No, it's the number of sides. So that'd be 3 times 180, sorry, like this, divided by 5. And that'd be 540 divided by 5. That would be 108 degrees. So every single one of these interior angles is going to be 108 degrees. And it only works with a regular. Okay, let's keep going. Central angle of a 5-sided shape is 360 degrees divided by 5. And you grab your calculator. 72. How else could you have found this? Oh no, central, not, never mind. Central. Central, it is what it is. Exterior angle of a 5-sided, it's 360 divided by 5 again. It's the same formula as the central angle. That'd be 72. But how else can you find it? Or exterior angle would be 180 minus, what was my interior angle? 108, right? So you just subtract 108 from it, and guess what? You get the same answer. You should. Right? You should get the same answer, or else we're doing something wrong. And the number of diagonals. I'm going to take a little bit more room for this one. If you could draw a pentagon with me. I know, I feel your pain if you're not artistically inclined. This is a bit of a... But number of diagonals of a 5-sided shape is a weird formula. It's n times n minus 3 divided by 2. So you would just go 5 times 5 minus 3 divided by 2. If you get a decimal, you did something wrong. Okay, you gotta go back to the drawing board. 5 times 2 divided by 2. You can actually in this case cancel this out if you see it. But it's 5 times 2 is 10 divided by 2 is 5. Okay. So this is telling you how many diagonals you'll be able to draw inside a pentagon. And I'm going to use a different color. So diagonal would be if you connect any two corners. This would not be, this is already a side length, but it's inside. So this one, there, from there to there, from there to there, that's 2 already. Okay? Then you could connect, if you wanted to, you could connect this corner to this corner. That's 3. You could connect this corner to this corner. That's 4. And there's one more, right? There's this corner to that corner. So there's your 5 diagonals. And this is going to get really crazy once you have more. I would never recommend you draw them out. Like, it's just, you're going to miss one and then you get it wrong. Even though the province says it's okay to do it that way, I would just say stick to your formula. Okay, stick to your formula. So these are the 1, 2, 3, 4, 5 formulas that you're going to use from time to time. Okay. So I'm going to ask you this, okay? Update your study sheet. Let's go to page 34. I'm just going to say update study sheet. Basically page 32 to 33. And, hold on, and fill up, did you copy that? Plus page 35. I'll explain page 35. It is fun. You can do it really quick if you know what you're doing. Let's go to 35. I don't want you to do 34 just yet. I'm going to ask you to fill some in. We have 6 minutes still, so I'm good. I'm good. Prefixes, write these down. You're going to need to have these on your study sheet. We've got triangle. We've got quadrilaterals. Then we've got pentagon. What comes after pentagon? Hexagon, yeah, hexa. Hepta, that's 7. Octa. Nona. Deca. 11, I don't know, I think they wanted to go home on a Friday, and so they didn't come up with a name. So it's just dodeca. Dodeca. That's 12. So 11 doesn't have a name. 10 is deca, nona, octa, hepta, 6, 5, 4, 3. Fill this in. I'm going to zoom out a little bit so I can see the whole thing. So I'm going to ask you to figure out the sum of interior angles. So basically, sum of a 3-sided would be 3 minus 2 times 180. That's just 1, right? Right? 1 times 180. You don't have to do the formula if you don't want. But for a triangle, it's 180 degrees, which you already knew. What's the interior angle of a 3-sided? You'd use this formula. 60, yeah? 3 minus 2 times 180 divided by 3. And that would be 60 degrees. Exterior angle. We could use this formula. What would that be? 360 divided by 3? 120. Or you could use 180 minus 60, correct? Regardless, you get 120. I don't need you to necessarily write out the formulas. I just need to have all of these cells filled in. Does it make sense that the interior and the exterior, what do they add up to? You see that they add up to 180? That's what we wanted. So that's a way to verify. And then find the central angle. Central angle is 360 divided by 3. Central is 120. All I need you to do is fill in this. It gets you to practice the formulas, and it will give you some of the numbers you will use a lot, so you can draw them from here. So update your study sheet, page 35. That's all I'm going to ask you to do. I would expect you by tomorrow to know how to use those formulas. Okay. Thank you, guys. And keep practicing the mystery angles if you still need more practice, all right? So just go back and do those questions.